So we're in section 9.3. We're going to talk about inscribed angles and how they are related to the arcs in our circle. All right, so on Friday, we talked about central angles. We've been talking about central angles and arcs and how the arcs and angles are related. And we decided that we have a central angle. The vertex is at the center of the circle. That the degree measure of the central angle and the degree measure of the arcs are the same. So we have a vertex. If we have our vertex at the center, the arc and the angle have the same degree measure. Well, we want to talk about a new kind of angle today. So first, let's talk about what an inscribed angle is. So an inscribed angle is an angle in a circle with its vertex on the circle and the sides are chords of the circle. So our vertex is on the circle and the sides make chords of the circle. Let's draw a picture of an inscribed angle. So there's our circle, there's our center. So this is circle P. And here's our inscribed angle. And I'm going to call this angle AVB. So we say that angle AVB is inscribed in circle P. Inscribed just means written inside. So it's inscribed in circle P. We also say that angle AVB is an inscribed angle. And we say that arc AB is intercepted by our angle, by angle AVB. So arc AB is the intercepted arc of angle AVB. And we have our vertex here on the circle. And our inscribed angle, the center doesn't have to be in the middle of the inscribed angle. We can make an inscribed angle that's really small. I could draw another one over here like so. So the center doesn't have to be inside the inscribed angle. That would also be an inscribed angle. So as long as our vertex is on the circle, we have an inscribed angle. And what we're interested in today is how does the measure of the arc compare to the measure of the inscribed angle. You know that if we have a central angle, the measure of the arc and the measure of the angle are the same. We want to figure out how the measure of the arc and the measure of the angle are related when we have an inscribed angle. So to do that, we're going to look at an activity. This is from your book, but I'm just going to grab this page and we're going to fill out this little chart to help us figure out about inscribed angles. We're going to go through this together. So here's our picture. Now, I know in the picture here it looks like this could be a 90-degree angle. That's not necessarily the case. So what I'm going to do is we have our inscribed angle, angle AVC. So there's our inscribed angle. And like we talked about the other day, on our hint, we have, what part of the circle is segment VP? Nick? What part of the circle is segment VP? Well, segment, or point P is the center of the circle. V is on the circle, so what do we call that? What segment goes from the center of the circle to the circle? The radius. Perfect. So segment VP is the radius. The hint that we had the other day is if we're not sure how to solve a problem, draw in another radius. They put it in a dotted line. I'm going to put in a solid line. So they put in the radius like so. Now this is not necessarily a 90-degree angle. It just happens to look that way in the picture. What do we know about all radii of the circle? Their lengths. What do we know about the lengths of the radii? They're all the same. So this side of this triangle is congruent to that side. So this triangle here is an isosceles triangle. These two sides are the same. If these two sides of the triangle are the same, what does that tell us about these two angles, Ashley? If we have two sides of a triangle that are the same, what do we know about the two angles? They have to be the same. So angle 1 and 2 are always going to be the same. So using that because we know we have an isosceles triangle, let's start filling out our chart. If measure of angle 1 is 20 degrees, what's measure of angle 2? 20 degrees. If measure of angle 1 is 30, what's measure of angle 2? 30, 40, and x. All right, so now we're interested in a measure of angle 3. What we're going to do now is think back when we talked about triangles, and we called angle 3 a remote or an exterior angle of the triangle. And angle 1 and 2 were called remote interior angles of the triangle. So we know that if we add angle 1 and angle 2 plus this angle, they have to add up to 180. And these two angles have to add up to 180. So that tells us that angle 3 has to be the same as these two put together. Because this plus this is 180, this plus this is 180. So angle 3 has to be the same as angle 1 and 2 put together. When we talked about triangles, we said that the remote interior angles were congruent to the exterior angle. So we're going to use that idea here. We know that angle 3 has to be the same as 1 and 2 put together. So if measure of angle 1 and measure of angle 2 are both 20 degrees, what's measure of angle 3? 40 degrees. This has to be 60. If they're both 30, if they're both 40, that has to be 80. X plus x? So 2x, there we go. All right, we're almost there. What kind of angle for the circle is angle 3? What do we call that angle? It's not necessarily 90 degrees, but we gave it a name. Its vertex is at the center. So what kind of angle is that for the circle? We just talked about it. Inscribed is the vertex is on the circle. Our vertex is at the center. So we called it a, remember Preston? The vertex is at the center. There's your hint. The vertex is at the center. Central angle. Angle 3 is a central angle because the vertex is at the center. How is a measure of the arc and the measure of the central angle, how do they compare? We just talked about it. The measure of the central angle and the measure of the arc. They're the same. That's how we just figured out the measure of the arc is the measure of the central angle. So the measure of arc AC is the same as the measure of the central angle. So if measure of angle 3 is 40 degrees, what's going to be the measure of our arc? Angle 3 is the central angle. AC is 40, 60, 80. Has to be the same. And 2x. So looking at the chart, how does the measure of the inscribed angle, angle 1, compare to the measure of the arc? To go from the angle to the arc, we multiply by 2. Go from 20 to 40, 30 to 60, 40 to 80, x to 2x. So the arc is twice as big as the inscribed angle. And we figured that out by drawing a triangle here. Two sides of the triangle were radii, so they're congruent. And we could figure out the measures of those angles and how the measure of the inscribed angle compared to the measure of the intercepted arc. That's going to be our theorem about inscribed angles. So we'll write that down. This is our inscribed angle theorem. And this is our big idea for this section. The inscribed angle theorem says the measure of an inscribed angle is half the measure of the intercepted arc. Or we could say, going the other direction, or the measure of the intercepted arc is twice, 2 times, the measure of the inscribed angle. And my picture, the way I usually like to draw this is if we draw our circle and we draw our inscribed angle here. To go from the angle to the arc, we multiply by 2. So to go from our inscribed angle to our arc, we multiply by 2. To go from the arc to the angle, divide by 2. So go from the angle to the arc, multiply by 2. Go from the arc to the angle, divide by 2. So that's our theorem about inscribed angles. That's our main thing that we're talking about today. So questions about our theorem? All right, let's look at a couple of examples using this. So these first 2 examples will be should be pretty easy. So here's our circle. Our inscribed angle, I'm going to call this ACB. And this is 26 degrees. And we want to find the measure of arc AB. So we know the inscribed angle is 26 degrees. So how are we going to find the measure of the arc AB? What are we going to do, Madison? Multiply by 2. So the measure of arc AB is 26 degrees times 2, or 52 degrees. So to go from the angle to the arc, multiply by 2, and we're set. So for this one, slightly different. This is 50 degrees. We want to find the measure of angle ABC. So the arc is 50 degrees, so how are we going to find the measure of the angle? Divide by 2. So the measure of angle ABC, 50 degrees divided by 2, and I get 25 degrees. Angle to the arc, multiply by 2, arc to the angle, divide by 2. Not too complicated. Questions on those examples? No questions? Okay. So let's talk about a couple of important results we call corollaries. So these are things that we can figure out pretty easily from our original theorem. So let me draw a picture and we'll talk about this one. This one's pretty easy to figure out. Here's the center of my circle. So this is circle P. I'm going to draw in a diameter and an inscribed angle. And we'll call this this is B, D, and A. All right. So looking at this picture, what kind of arc do we have going from B to D? Semicircle. So arc BD is a semicircle. And I guess I should put a C here to make sure you know what we're talking about. So we could say arc BCD is a semicircle. We could go around either direction, it doesn't matter. Arc BCD is a semicircle. How many degrees is a semicircle? 180. So the measure of arc BCD is 180 degrees. So if this arc is 180 degrees, the measure of angle BAD, what's going to be the measure of the inscribed angle that intercepts that arc? To go from the arc to the angle, what do? Divide by 2. So what's going to be the measure of angle BAD? 180 divided by 2? 90. So the measure of angle BAD is 90 degrees because the arc is a semicircle. The arc is 180 degrees. So that's our first important result. The measure of an angle. I'm going to put a little red star here. We just figured out. The measure of an angle inscribed in a semicircle is 90 degrees. So no matter where we inscribe this angle, it could be I could inscribe this angle anywhere as long as it intercepted that semicircle. And we would always get a 90-degree angle. So it doesn't matter where I put those inscribed angles, as long as it intercepts a semicircle, that angle is going to be 90 degrees. So this angle would be 90 degrees, this angle is 90 degrees, this angle is 90 degrees. It doesn't matter where I put it, as long as it intercepts that semicircle, those angles are going to be 90 degrees. So that's our first important result. We have, if our angle intercepts a semicircle, if its endpoints are on a diameter, then to measure that inscribed angle has to be 90 degrees. Any questions on that important result? All right, let's look at another one. So here's our picture for this one. Have a few more lines in this one. And we're going to call this, we'll call this point B, C, D, and A. And I'm just going to look at one set of angles. So angle CBA and angle CDA both intercept arc AC. What does that tell us about those two angles? They have to be the same. They intercept the same arc. This arc is whatever it measures, 57 degrees or whatever. So each of these has to have the same measure. If they intercept the same arc, they have to have the same measure. So that's our second important result. I'll write angle, sorry, I want to do that in black. So angle CBA is congruent to angle CDA. And it doesn't matter where we draw it, how we draw it on our circle. Our important result is two angles, two inscribed angles, that intercept the same arc, are congruent. So if our inscribed angles intersect the same arc, they have to be congruent. So we could say also here that angle BCD is congruent to angle DAC because they both intercept DB. So any two inscribed angles that intercept the same arc are congruent. So that's our second important result. So we know that the inscribed angle, to go from the angle to the arc, we multiply by 2. To go from the arc to the inscribed angle, we divide by 2. If we inscribe an angle on a semicircle, it has to be a 90-degree angle. And if two angles, inscribed angles, intercept the same arc, they have to be congruent. So let's look at a couple of examples using this idea. So here's our picture. And we'll label our points. So we have A, I'm going to call this one A, C, D, and B. So we want, and we know that this is 24 degrees. we want to find the measure of arc CD and the measure of angle CBD. I'll call it angle B. So we want to find the measure of, I'll highlight it in red. We want to find the measure of that arc, and we want to find the measure of that angle. All right, so what are we going to do here?
Well, we already know, we already know that A is 24 and B is 24.
They intercept
Yeah.
the same arc. So because these two intercept the same arc, measure of angle B equals the measure of, forgot my B here, equals the measure of angle A. So the measure of angle B has to be 24 degrees because they intercept the same arc. Now let's find the measure of the arc. So this is 24 degrees. I'll put that in red because we figured that out. So let's find the measure of the arc. How do we find the measure of the arc here?
We would times 24 by 2.
Multiply by 2. So the measure of arc CD is 24 times 2, or 48 degrees. And we could have done this problem, we could have done it in that order also. We could have said, well, I multiply 24 by 2 to get 48. I know that's a 48 degree arc. And then to go back to the angle, I could say, oh, I need to divide by 2 to get my angle, divide 48 by 2 and get 24. So we could do it that way also. But if we recognize right away that they intercept the same arc, we know those two angles have to be the same. Questions on that example? Okay, one last example. So here's our circle for this one. A little bit different this time. And this is 36 degrees. And for this problem, we know that segment AB is parallel to segment CD. We want to find the measure of arc AC. So we know these two segments are parallel. So if those two segments are parallel, what does that tell us about this angle and that angle? The segments are parallel, so what does that tell us about the angles? They're congruent. Angle ABC is congruent to angle BCD. Remember what we called those kinds of angles for parallel lines? They're not supplementary. We're not adding them together. Well, complementary means they add to 90 degrees. They're congruent. This is our transversal. Are they on the same side or opposite sides of the transversal? Opposite. So they are alternate. Interior. They're between the parallel lines. So they're alternate interior angles. So we know that this angle is 36 degrees also. Now we know this angle, so how are we going to get arc AC? We multiply by 2. So the measure of arc AC is 36 times 2, or 72 degrees. So for this particular problem, we had to remember something about parallel lines. For your homework, you're going to have to use parallel lines. You have to use what you know about triangles. There are also problems that involve angles and quadrilaterals, stuff that we talked about last semester that you're going to have to remember in order to do the homework. So it's not all going to be like these examples we did back here, where we just have nice find the arc, find the angle. We're going to have to remember some things that from what we've learned before and apply those to the homework problems. Like this one, we had to remember something about parallel lines. All right, questions on that example? Okay.